Let's evaluate the limit as x approaches 0 of 1 minus cosine of x divided by x. If we plug in 0 for x in the numerator, we get 1 minus 1. In the denominator approaches 0, so we get the indeterminate form 0 over 0. We can't say what that would be, so what we have to do is remove 0 over 0 somehow and then evaluate the limit of whatever is left. The way to do that is to multiply the numerator and the denominator by 1 plus cosine of x. So 1 plus cosine of x divided by 1 plus cosine of x. And this is equal to limit as x approaches 0. The numerator is 1 minus cosine squared of x, and the denominator x times 1 plus cosine of x. Now recall this numerator 1 plus cosine squared, that's equal to sine squared of x, because sine squared plus cosine squared equals 1. So we'll rewrite this as limit x approaches 0 sine squared x divided by x times 1 plus cosine of x. Now we're going to split this up into two limits. First, let's write it like this. Limit x goes to 0. Sine square, we're going to write as sine of x times sine of x, and divided by x times 1 plus cosine of x. And now let's split it up into two limits. The first limit will be limit as x approaches 0 sine of x divided by x times the second limit as x approaches 0, what's left, which is sine x divided by 1 plus cosine of x. Now recall that this first limit, it is equal to 1. This was shown in an earlier video. You can look for that. So this is 1 times, and then the second limit, the numerator, as x goes to 0, sine approaches sine of x approaches sine of 0, which is 0. So the numerator is 0, and denominator is 1 plus, when x is 0, cosine of 0 is 1, so 1 plus 1 is 2. We get 1 times 0 over 2, which is equal to 0. Therefore, the limit as x approaches 0 of 1 minus cosine of x divided by x is equal to 0. This is an important result that will be used later to prove, to derive more complicated limits. For more videos, visit www.mathprepvideos.com.